Good evening, Lamai. Right. Today we are going to discuss about the identification tests of organic compounds. Right? Organic compounds identification test right? Right? Let's start. Okay. This will be the first session of the today's discussion. And lately, if we had enough time, we'll discuss about some conversions related to benzene as well. Right. Let's start the session. Right. With the identification test of organic compounds. Right. So I'll provide you the tute lamai. I'll give the tute mama next class lamai tute denna. I forgot to give the tute. Right. Tutes are there. Right. I'll give those things to you at the next class. Right. Right. Let's begin the session. Identification tests. Right. We'll start with the hydrocarbons. Let's start with the hydrocarbons, right? Under hydrocarbons, basically we have the alkanes, alkynes, and the benzene. No? So basically, alkanes are not involving in much of reactions, right? So there are no identification tests for alkanes, there, right? So as hydrocarbons, we have to discuss about the identification tests of alkenes and alkynes, there, right? Let's start with that thing, right? Number one, for the hydrocarbons. Under that, basically we are referring to tests with alkenes and alkynes, right? Alkenes and alkynes. And this is very important for your MCQs, right? This section today is very important for your MCQs as well as for the next part. We are going to discuss the isomerism part, the isomerism question. Question number 4, the structured question, right? For that question as well as for your MCQs, this section is very important, right? Okay, see, alkenes and alkynes, the identification, right? First, let's discuss about the identification of the carbon-carbon 5 bond, which is known as the identification of the unsaturation, right? Unsaturation or unsaturated 5 bonds. Identification of the unsaturation. So that means, right, carbon, 5 bonds. Existence of carbon 5 bonds, right? So basically, what we can do to identify these things, the 5 bonds, is actually, so if you are to add, right, if you are to add the Br2 CCl4, if you add Br2 CCl4 or some basic KMnO4, right, normally called diluted basic KMnO4 to a compound with a carbon 5 bond, right? At least one carbon 5 bond. It could be alkenes or it could be alkynes, where the carbon 5 bonds are appearing. So if you add these two reagents, one of these reagents, to a compound containing carbon 5 bond, right, some decolorization of the reagent occur. So basically Br2CCl4 is orange in color. Br2 organic is orange. So that color will be turned to colorless. As Br2 consumes when reacting with 5 bonds, right? With alkenes, these kinds of compounds will form with alkynes as well. This kind of compound will form right? So as the Br2 consumes, its color will disappear. So Br2 in organic clay is orange colored. When the Br2 consumes, when reacting with the organic compound, its color will disappear. So a color change would occur if you add some Br2 in organic medium to these alkenes or alkynes. So what happens with the KMNO4 stuff? So the KMNO4, that is purple in color. So what will happen? Its color will change. The color will disappear, and you will end up with some NMNO2, some brownish black PPT. That is what happens, right? While the alkene or the alkyne oxidizes, the KMNO4 reduces to MnO2 as you are using a basic medium. KMNO4 reduces to MnO2, not towards the MnO4 minus, but to MnO2, which is a brownish black PPT, right? So alkyne or alkene will get oxidized. So if it was an alkene, it will get oxidized to diol. Remember the Bayes test, right? This is known as the Bayes test as well, right? Bayes test. Right? Even with the alkynes, this kind of color change will occur, but the compound you produce is not there in your resource book. With the alkynes, the compound you produce is not there in the resource book, so that I'm not going to write that compound, right? No need, no. But the observation is still the same, right? Even with the alkynes, right? No. Bayes test. What else? Right? So not only the basic KMNO4, but also the acidic KMNO4 can be used. Even you can use the acidic KMNO4. If these alkynes and the alkenes are to be reacted with basic KMNO4, that means some weak oxidizing agent, the acidic condition is much stronger than the basic condition, right? This is more strong oxidizing agent than the basic KMNO4. So definitely the 5-bonded alkenes and alkynes definitely should react with those. So even though that reaction is not there at the resource book, still you should know that a reaction, that kind of observation is possible with the acidic KMNO4 as well. So but at this case, right, the acidic KMNO4 reduces to Mn2 plus, right? Not towards the MnO2, but towards the Mn2 plus as the acidic medium is used. So the color change is actually purple to colorless. So clearly come up with the color changes. So you can color this stuff in your note, right? That is what happens even in the acidic KMNO4. Such kind of a thing will occur. Right now? Okay, just write this stuff, right? That is not in written in your tute, but that is also available. So for MCQs, they had asked these kind of questions as well, right? This is what you should know. And then, right, even though the benzene is considered as an unsaturated compound, benzene is not going to react with these guys, right? Last day we had discussed about the benzene chemistry, that video, no? I think you had gone through that video about the benzene, or you had been there, no? In the class, right? The benzene video, right? Benzene lesson, right? There also we had discussed, right, that even though benzene is considered as kind of an unsaturated compound, it won't react with these two guys. It won't give the positive results for the test for unsaturation, right? We had discussed about those things, right, in the benzene chemistry. So let's write that thing as well here, right? So this is these are the reactions for answer reaction, right? Admit test, but benzene won't, right? That we discuss about that thing as well. So it's a special note. The benzene with the benzene, even though it's unsaturated compound, CCH6 is unsaturated. Hydrocarbon, but still it won't give the positive results with the set for unsaturation. Even the acidic KMnO4 ring is not going to react. Ring is not going to react, right? No reaction. Keep that in mind. Is also very important stuff, right? You should know that, right? With the benzene, even though benzene is kind of unsaturated compound, right? It won't give you positive results for the test for unsaturation, right? It's very important, right? This is all what you should know about the test for unsaturation, right? So this one will react ළමයි. දැන් අර බෙන්සීන් රේට් කරනකොට මෙන්න මේ වගේක් රේට් කරනවද? මෙන්න මේ වගේක් ගත්තොත් this is not benzene න? බෙන්සීන් යන්නේ නෙවෙයි කියන්නේ. බෙන්සීන් වගේ එකක් කියන්නේ. බෙන්සීන් නෙවෙයි. මෙයා රේට් කරනවා. It's just a alkene, right? A double bond, carbon carbon double bond situation. This guy will react, right? So you have the 5 bond here, complete 5 bond here. This guy will react, right? Not the benzene, but this way. So this is referred to as right. It's kind of a cyclohexene. Is referred to as cyclohexene. That will react, huh? Cyclohexene. 6 carbons are there, ene is there, cyclo compound is there, right? Okay, test for unsaturation will be answered by this one as well, right? So this is about the test for unsaturation, right? Okay, let's discuss few more stuff available with the alkynes, especially with the thermal alkynes. This is about the next. Let's discuss about the right identity tests available with the terminal alkynes, right? This is clear, no? So all the things are there at the node, right? So right, you can write this thing as well. Let's go towards the terminal alkynes, the identity tests of terminal alkynes, right? Right, let's copy the part B. දැන් ළමයිනි මෙතන මොකක් කරලා කතා වෙන්නේ වාගේ ඉගෙන ගත්ත reactions, right? මොකක්වා ඉගෙන ගත්ත කතා කරපු reactions තමයි මේ කතා වෙමින් තියෙන්නේ, right? අලුතින් එකක් දෙයක් වගේ තමයි discussion එකේ තියෙන්නේ. මුතුගක් reactions වල දන්නේ වාගේ. අන්තිම හරියට පොඩ්ඩක් අලුත් reactions ටිකක් හම්බ වෙයි. But the first reactions are actually known, right? The second part, identity test of terminal alkynes. You know the stuff, no? Terminal alkynes means acidic alkynes, right? So these are terminal alkynes, right? When you have a triple bond at the terminal carbon, and you know this hydrogen is referred to as an acidic hydrogen, right? These are terminal alkynes, right? Right. This is about the identity tests of terminal alkynes. So we have 4 of those. We have learned 4 special reactions involving with the terminal alkynes. This is about those 4 reactions, right? So first thing, right? Actually, 2 precipitations can be done. Basically, you can come up with ammonical silanitrate, right? This can be written like this as well. Amine complex. One can write it as ammonical silanitrate. All is the same region, right? And one can write it as the tolerance region. All the things represent the same region, right? Ammonical silanitrate, right? So if you add that region, the tolerance region, to a terminal alkyne, you will come up with a white PPT. You will come up with a white PPT, right? This is the chemical responsible for that, right? White PPT. So that is the observation, no? So I write it here. It will be a white PPT. White PPT. Right. So, and you can come up with ammonical copper chloride as well. Ammonical copper chloride as well. Cu2Cl2. One can write the same thing as copper amine like this. Right. So yes, right. So this is copper plus 1, right? Don't forget that this is copper plus 1, right? Here the copper plus 1 oxygen state is available, not the 2 plus, right? It's also referred to as ammonical copper chloride. Right? Then you will get some PPT as well, right? Red brown PPT. Red brown PPT. Due to the formation of this compound. Right now? Red brown PPT. Right? Both are precipitates. One is red brown, the other one is white. Right? Then what are other reactions, other tests we can use to identify the terminal alkynes? Yes, we can come up with some sodium, as terminal alkynes are acidic. Acids will react with metals to produce salt and H2. So H2 gas will liberate. Colorless gas liberation. One can say colorless effervescence, right? So that thing will be given with the salt. With the salt. This is salt. That is your salt, right? It's a colorless solution. It's a salt. Colorless solution with a colorless gas is a salt. Even in the soda amide, NaNH2, you can see the same kind of observation but with a different gas. This time it is the NH3 gas. Again the same salt will be produced. right? So when studying, right, carefully study here, right? So these two are precipitates, so that some covalent compounds, covalent bond is appearing between the carbon and the metal, between the carbon and the metal of these two precipitates, covalent bond is appearing, right? But here, between the carbon and the metal, carbon and sodium, you have an ionic bond. So correctly write those two things, right? For precipitates, it's a covalent bond. For solutions, it is the ionic bond appearing, right? They will check that carefully, right? So when writing the species responsible for these observations, just correctly write those things. These are sodium acetylides, and these are the silver acetylide and the copper acetylide, right? Sodium acetalides are ionic, while the silver and the copper acetalides are covalent. That is why they won't dissolve in water, right? This is why those will appear as a precipitate, right? No? So this is all about the identification of terminal alkynes, right? No, it's clear. All the things are there in your note, no? So I think this is not written there. This is not written there. So you can add this one in your note. This is not written. Just add this one as well, right? The fourth kind using the NaNH2, giving you a colorless gas and a colorless solution, right? And this gas is basic, right? It is also important to note that the basic gas, right? The basic gas. It's a basic gas, right? Okay. Let's discuss about the identification tests of other compounds. This is all about the hydrocarbons, right? Let's go towards the identification tests of other compounds. The identification tests of aromatic compounds, right? So identification tests of aromatic compounds here, normally known as highly activated benzene rings. Highly activated benzene rings. Highly activated benzene rings. So such two compounds are there. Such two highly activated benzene rings are there, right? So one thing is phenol, the other one is aniline. So let's discuss about those things, right? The test for anilines and phenols. Let's start with the phenols, right? Okay. Let's start the session with phenols, right? Part A. Any tests of phenols, right? Okay. So phenol is this kind of a compound, right? Where you have a OH group connected to the benzene ring, right? This is phenol, right? So identify phenol, right? We have four number of tests, right? Okay, let's see what we can do to identify the presence of phenol, right? So we can add the Br2. We can add the Br2 aqueous. Then what will happen? So we will come up with kind of a white PPT. White PPT. We'll come up with white precipitate due to the formation of this compound. Due to the formation of this compound. We had discussed this thing with the benzene conversions lesson, right? This is referred to as a white PPT. The name of this thing is 246 tribromo phenol. 246 tribromo phenol. Due to the formation of that thing, right, a white PPT will form, white precipitate. This guy won't dissolve in water, but that is why it appears as a white PPT. So just by adding a Br2, you are able to come up with that. Normal benzene, right, won't connect any Br atoms if only the Br2 is added. With the normal benzene, you won't see the connection of connecting of the Br atoms by just adding Br2. We need a catalyst for a normal benzene to add some Brs. But when it comes to phenol ring, the phenol, right, it's not a normal benzene ring, it's a highly activated benzene ring with the phenol, so that you can add 3 bromine groups, 3 bromine atoms to the ring like that, even without the catalyst, right? So that these phenols and anilines are considered as highly activated rings. Even with the aniline, the same thing happens. Not only the Br2, but you can come up with the Cl2 as well. If you are to add some Cl2 here, it will create the 246 trichlorophenol, right? That is also white in color, right? No worries with that as well, right? Okay, that is the first hydrogen test for the phenols, right? So then, what else? So you can add some diazonium salt in basic medium. You can add some diazonium salt in basic medium. So this is the diazonium salt. Last day as well we had discussed about diazonium salt, right? So in basic medium, if you add some diazonium salt, you will come up with some azo dye or azo dye, actually which are colored. It could be as a solution or a precipitate, anyway colored, normally orange in color. Orange colored compound is known as azo dye. So you should know the structure as well. This is the structure of the azo dye. Should know that thing as well. This is also, this will be a very important reaction, right? This will be asked. It's also a highly asking question, right? In structured paper, right? This guy is orange in color. This is what happens when you add the diazonium salt to phenol, right? Okay, the diazonium salt to phenol එක දැම්මොත් ඔය සිටුේෂන් තමයි ඉන්නේ. අර වාගේ ටියුට් එකේ තියෙන්නේ මෙයාම තමයි හොඳේ. අර මේකම තමයි පොඩ්ඩ බෙන්සින් රින්ගේ හැබැයි හරවල තියෙන්නේ N2Cl කියලා, right? Same stuff, right? Okay, this is referred to as diazonium salt, right? What else we can do? So you can come up with neutral or natural FeCl3. If you add neutral FeCl3 to phenols, right, you will come up with a purple solution. So actually this reaction is analogous to the reaction of Fe3 plus with salicylic acid. This reaction is analogous to the reaction of Fe3 plus with the salicylic acid. If you remember that reaction, Fe3 plus with the salicylic acid, still you got a purple solution, right? Actually, salicylic acid means it's another benzene ring where you are with a OH group and a H group. In salicylic acid, you have a OH group as well as a C double bond OH group. So OH and C double bond OH. OH and a carboxylic group is connected to the benzene ring. That is what salicylic acid is. No need to know that structure, right? Actually, not, they are not going to ask you to give you the structure of the salicylic acid. But if you are to search through the internet, you will see that salicylic acid is actually carrying some benzene ring. It is with the benzene rings, the salicylic acid, where you have with a OH group and a C double bond OH group connected to that ring, right? So this reaction is also analogous to that. This guy is also giving you the purple solution, right? When the Fe3 plus is to react with phenol as well, with the salicylic acid as well as with phenol, the Fe3 plus will give you a purple solution, right? Okay. What else? Next one. So phenol is acidic. This hydrogen is acidic. This OH acidity is there. This guy is acidic. So, right, you can add sodium. You can add sodium here to this one. So you will produce a salt and H2. Salt and H2. If you are an acid, normally those will react with metals to form the salt and H2. Liberation of H2. The gas bubbles, colorless gas bubbles, is a good observation, right? So you could think of that as well. So you release some colorless gas here. Right? So that thing will be produced with the salt. Salt is going to be now like this. Salt and H2. Anyway, this is the major observation. Releasement of colorless gas bubbles. Right? Right, no? Okay. These are the 4 tests we can carry out to identify the presence of phenol in an unknown solution. Right, no? So, this is how phenol identify කරන test එක. හරිද? Alright. Clear, no? Right. මොනවද phenol කතාව. හරි. දැන්ලා මේ ටික මේ ටෙස්ට් එක ඔක්කොම කතා කරමු, right? මොකද මේ ටික වාට ඕන වෙනවා මේ ඉස්සරහට කතා කරන් තියෙන දේවල් වලටනේ. අයිසොටෝප්ස්ගේ පාට තමයි ඉස්සරහට යන්නේ. හරි. දැන් අපි මේජර් දෙයක් විදිහට අපි මේ කන්වර්ෂන්ස් ඉවර කරමින් ඉන්නේ. අද අපිට කරන්න පුළුවන් මේ ඉතුරු බෙන්සින් ටික. එතකොට ඊට පස්සේ අපි යන්නේ අයිසොටෝප්ස් කියන question එක. Question number 4. Question number 4 ආගේ A level එකේ structured question එක. හරි. මේ question එක කරනකොට මේ දැනුම අවශ්‍ය වෙනවා. The knowledge of finding test. For MCQs as well, you need this knowledge, right? It's like me theory part එකක් දෙන්නේ. ඒ ටික කතා කරලා ඉවර කරමු, right? හරි. එතකොට මේ තමයි phenol identify කරගන්න identifying test එක. Right? Okay. Now let's go towards the next highly activated benzene ring. Right? That is actually aniline. Let's discuss about the identifying test for the aniline. Right? aniline phenol දෙන්න ඔයාලට මතකයි නේද? පාර වීඩියෝ එක කලින් වීඩියෝ බලුණා. හරි. මේ මිස් ක්ලාස් එකේ දාපු lesson එක බලුණා. You should know about the aniline and the phenol, right? Those are referred to as highly activated rings. Right? So let's come up with the aniline. Right? Sorry, aniline. Right. What is this aniline? Aniline කියන්නේ කවුද? Aniline කියන්නේ මෙන්න මේ වගේ කෙනෙක්. This is the aniline. These are aniline, right? This is the aniline, right? So it is also a highly activated benzene ring, right? Aniline. So what can we do to identify the aniline, presence of aniline in unknown mixture, right? We can carry out these tests. මේ වැඩි කොහොමද කරගන්න පුළුවන් කියලා. aniline එක තමයි අර benzene ගේ phenol ගේ වගේම tribunal product එක තව දිනනවා. So as this one is highly activated ring, so you can copy the tribromine product. If you add some Br2 in CCl4 medium, sorry, no need of CCl4 medium, it's better to copy some aqueous medium to copy the precipitate, right? So what will happen? Br2 will get decolorized and white PPT will form, right? White PPT will form. Right? So it's kind of white PPT. Right, due to the formation of this one. The tribromine product again is known as the 2,4,6 tribromo aniline in this case. 2,4,6 tribromo aniline. But normally 2,4,6 means 2, 4 and 6 are the positions of the benzene ring. Right, actually which is the adjacent to the connected group and directly opposite to the connected group. May 2,4,6 numbers එක එහෙම ළමයි එන්නේ හරි. And link එක මෙතන number 1 major group එක 2 3 4 5 6 හරි. Adjacent දෙන්නයි directly opposite එක තමයි 2,4,6 කියලා කියන්නේ. ඔන්න සාමාන්‍යයෙන් ortho para positions කියලා. We'll discuss that in later, right? Okay, that is 2,4,6 tribromine aniline. When you are to produce this one, it can be appeared as a white PPT. What else we can use to identify the aniline? So we could copy this one, the NaNO2HCl. We should apply NaNO2HCl at 0 to 5 no, at the room temperature, right? Normal temperature. What will happen? This NH2 group will be converted to OH. True diazonium salt, NH2 thing will convert to OH. So what is the special observation? The observation of is actually releasement of N2 gas, colorless gas bubbles. Will produce the phenol, but the main observation is releasement of the N2 gas. With the use of that, you can identify the presence of aniline, right? So what else we can do? So actually we can do like this, Lama. So we can add the NaNO2HCl at 0 to 5 Celsius temperature, and then we can add basic phenol. Let's examine what will happen here, right? When you are adding NaNO2HCl with 0 to 5 Celsius, what will happen? This aniline part will convert to the diazonium. This aniline part, the NH2 part will convert to N2Cl. As you are adding the NaNO2HCl at 0 to 5 Celsius, this will convert to N2Cl, right? N2Cl. To N2Cl you are adding phenol. To N2Cl you are adding phenol, or to the diazonium salt you are adding basic phenol. What will happen? The same reaction again. What is that reaction? That is the formation of azodite. That is orange color dye. Right? So that is the formation of this one. The same compound, right? What you have written with the phenol as well. Same reaction, no? Azodite, right? This orange colored compound is known as azodite, right? No? It is another way of identifying the aniline. Ultimately, you can come with this kind of a thing as well. As anilines are basic, it is basic, right? So some lone pair is there on nitrogen which can be donated. So it is basic. The phenols are acidic, anilines are basic. As those are basic, you could think of acid-base reaction with HCl as well. In what will happen? The salt will be produced. That means it will be water soluble, colorless solution. Water soluble. As you are producing the salt, it will dissolve. As you are producing the salt, as it is ionic, it will be dissolved in water. So that reaction also can be used to identify the aniline. Organic compounds lamay aniwaren ionic na, those will dissolve in water. When they are ionic, they will definitely dissolve in water, right? So that is why it becomes water soluble. But if they are not ionic, so some criteria should be met to dissolve in water. So that aniline is not going to dissolve in water. But as this guy is ionic, definitely dissolves. With acid-base reaction, you always produce some salt, no? So that it will dissolve, right? Okay. So we have a question, right? First, complete this one. Let's try to answer the question. Pahan, it's okay, right? No worries, right? So this is regarding the aniline. We have aniline katava, right? That is about identification of test of aniline, right? Right. අපි එහෙනම් යමු ඊළඟ කතාවට, right? This is all about the identity test of highly active benzene rings, right? Okay. මේක මෙන්න මේ reaction එක පොඩ්ඩක් ලියා ගන්න. මේක ඔයාගේ note එකේ නැහැ, right? These three things are there but not this one. Just write this one as well, right? This one. Right. Let's discuss about the identity test of alkyl halides, right? Next one is about the alkyl halides, right? Let's do this stuff, right? Number 3, identity test of alkyl halides. Right. See, so in your resource book, there's not that much of identity tests mentioned to identify the alkyl halides, right? But in questions, right, these kind of things are appearing. So we'll discuss kind of a test we could be able to do to identify the presence of alkyl halides, right? So it's like this. So we could do a test like this. So basically, when it comes to alkyl halides, you have a halogen, no? Let's say you have a chlorine, no, kind of thing, right? You have a halogen, no? So we can identify the presence of this halogen. That it should came from an alkyl halide, so that we can identify the alkyl halide as well, right? It's like this. So if you are to add the NaOH, if you add the NaOH here, So you can provide the OH minus ions to the medium now. So this OH minus ion comes to will connect with your alkyl group, and Cl minus will be left to the medium, right? හරි ඔයා ඉන්වර්ට් දැම්මම මොකද වෙන්නේ? OH minus කියන නියුක්ලියෝෆයිල් එක R group එකකට සෙට් වෙද්දී Cl minus කියන එක න එතනින් leave වෙනවා, right? So that then we can plan to identify the Cl minus, right? So what we can do? So basically we can come up with some identification tests related to Cl minus, right? So you can think of adding some Ag plus or PbP2 plus to this solution, right? Okay. So what they have written? Yeah, they have written any kind of halide identification, right? So you can come up with halide identification test here. So most probably you can add Ag plus or Pb2 plus ions. So that what will happen? So some kind of white PPT will appear. If it is a chloride, if it is a bromide, you could have different colors, right? Okay. So that is the idea. Right, let's discuss some more on this test. So it's like this. So your alkyl halide right could be a primary halide, secondary halide, or a tertiary halide. Could be, no, right? Could be a tertiary alkyl halide, or it could be a secondary alkyl halide, or it could be a primary alkyl halide. The special thing with the tertiary alkyl halides is actually even with water, even without using the NaOH, even with water, the tertiary alkyl halides are able to release the Cl minus ions to the medium. Right? Even with water, tertiary alkyl halides are able to release Cl minus ions to the medium by producing the tertiary alcohol. By producing tertiary alcohol, they will release Cl minus ions to the water. Right? To the aqueous solution, even with the water, right? But when it comes to secondary, right, those won't react with water, right? These guys won't react with water, but they will react with NaOH, right? These guys, secondary and primary RCl, won't react with water, but those will react with NaOH. If you are to add some NaOH, AQ like this, right? You come up with the alcohols and the Cl minus AQ, no? So that we can carry out the identification test for the Cl minus from here, right? That is what we are supposed to do to identify the alkyl halides, right? The Cl minus can be identified, right, using some halide and tests, right? Okay, no? That is the idea, right? So produce Cl minus can be identified using OLED. If you are to Ag plus ions, Ag is silver nitrate. You will get the white PPT as well as with lead nitrate or lead acetate. Right? That is a very important method of identifying alkyl halides. What you are doing is actually first you will release the Cl minus ions to the aqueous solution by reacting with NOH or with water for the tertiary alkyl halides. In that released Cl minus, the halogen will be identified by a halogen identification test, right? That is the idea of this test, right? This can be used to identify alkyl halides, right now. Okay, that is clear. Right. Let's move to discuss about the identification test of alcohols then. This for alcohols, right? Number 4. Identification test of alcohols. I'm just discussing, right? Going through the note, right? So you can actually go through that, right? Number 4 is about the identification test of alcohols, right? Identification of alcohols. To identify the alcohols, Lamai, there are a few tests available. Actually, we have 3 number of tests to identify the alcohols. Right? Let's discuss one by one. Right? So most common, the most important test is known as the Lucas test. Most important test to identify alcohols is known as the Lucas test. Lucas test, right? Let's discuss about this one, what this means, and what kind of a process is done here. It is like this, Lama. So first you are coming up with some alcohol, right? And what you are doing is actually you are replacing this OH group of the alcohol by the Lucas reagent. You are replacing the OH group of the alcohol by Lucas reagent. What is this reagent? The Lucas reagent is actually anhydrous zinc chloride with concave Cl. This is known as the Lucas reagent, right? So that's what will happen. This OH group of the alcohol will be substituted by a Cl group there. So as you are adding some Cl minus nucleophile, this OH here of your alcohol, OH of your alcohol will be substituted by that Cl provided by the zinc chloride HCl. Zinc chloride is actually catalyst provided by the HCl, right? So this is your alcohol that has been converted to an alkyl halide. Right? Actually, this observation here is actually a appearance of a turbidity. Appearance of a turbidity is the observation. So as alkyl halides are not dissolving in water, as alkyl halides are not dissolving in water, right? You could see it as a turbidity appearing in solution. ළමයි වතුරේ දිය වෙන්නේ නැත්තම් දෙයක් හරි වතුරේ compound එක දිය වෙන්නේ නැත්තම් dissolve වෙන්නේ නැත්තම් ඒක අපිට observe වෙන ක්‍රම හතරක් තියෙනවා. There are four kind of observations when a compound is not dissolving in water. One thing is actually the precipitation. Precipitate එකක් විදිහට අපිට ඒක පේන්න පුළුවන්. තව මොනවද ඉතින්? So another thing is the layer separation. When a compound is not dissolving in water, layers could separate, right? Like in oil and the water, the coconut oil and the water, you could see some layer formation because the coconut oil won't dissolve in water. Layer separation is another kind of observation we will observe when two things are not mixing together. තව විදිහක් තමයි ළමයි turbidity කියන එක. And තව විදිහක් තමයි colloidal solutions කියලා එක. Colloidal sulfur. You had came across the colloidal solutions, colloidal sulfur, milky sulfur. When not dissolving in water, it could appear like that. Colloidal solutions. Right? And then the turbidity. This is the fourth form, the turbidity. Turbidity can what? Turbidity means it's a kind of situation where you won't clearly see the other side of the test tube. The turbidity කියලා කියන්නේ මෙහෙම නේද ස්මජ් වෙලා වගේ පොඩි ඉන්නවා ඒ compound එක. මේ පැත්තෙන් දැන් බැලුවට පස්සේ ඔයාලට අනිත් පැත්ත හරියට වෙන්නේ නැහැ. පේනවා but ස්මජ් වෙලා වගේ. එහා පැත්ත ස්මජ් වෙලා වගේ වෙන්නේ හරි. පොඩි හරියට වෙන්නේ නැහැ ඔයාලට. හරි. ඒ වගේ සිටුේෂන් තමයි turbidity කියලා කියන්නේ. Right? So that kind of a observation could be seen with the formation of alkyl halide as it is not dissolving in water, right? Turbidity will appear. Right? So මේ ටෙස්ට් එක මෙහෙමයි කරන්න ළමයි. මේ ටෙස්ට් එකේ තියෙන්නේ මෙන්න මෙහෙම දෙයක්. හරි? This reaction is actually going through a right two-step mechanism. They have identified this reaction is going through a two-step mechanism. මේ reaction එක වෙන්නේ ළමයි two-step mechanism එකකින්. Right? It's going through a two-step. Is referred to as SN1 two-step, or one can say carbocation mechanism. This reaction is happening through a carbocation mechanism. So if you are able to produce a stable carbocation, if your alcohol is able to come up with a stable carbocation as an intermediate, this reaction will be more favored, because we know, right, if you are coming up with a stable carbocation, if your compound is stable, right, reaction is keen to go through that path then. So if a stable carbocation is formed as an intermediate, right, reaction will be easily go through that pathway, so that, right, the carbocation which will form, right, as an intermediate matters to the reaction rate, to the time consumed to give you the turbidity. That matters, right? If the reaction is more keenly done in less amount of time, the reaction will complete to give you the turbidity. If the reaction is very hard to do, reaction is not keen to be done, right? So then it will take much longer time to complete the reaction to appearance of the turbidity, right? So if your alcohol is kind of a tertiary alcohol, then the reaction is done in no time, because if your alcohol is tertiary alcohol, you will come up with a tertiary carbocation, which is known as the most stable carbocation out of primary, secondary, and tertiary. So the reaction will complete in no time. So appearance of turbidity is instant. So that is what you need to know, right? So this reaction, this is the theoretical background. And if you think of the observations, so your ROH, the alcohol, can be out of one out of three things. The ROH can be a tertiary alcohol or a secondary alcohol, or this ROH could be a primary alcohol. So if you are dealing with a tertiary alcohol, as the tertiary carbohydrates are very stable, the reaction will be done in with no time actually, right? Easily done, right? So if you have a tertiary alcohol, right, like this, right? So you get a instant turbidity. You get an instant turbidity with zinc chloride concrete Cl. You would get a instant turbidity. Right? If you are tertiary. But if you are secondary, right, to complete the reaction, or one can say to appear the turbidity with anhydrous zinc chloride and concrete Cl, right, some 5 to 10 minutes will be consumed. For a turbidity. Right? So if you are a primary alcohol, the primary carbohydrates are very unstable, or that not that much stable, so it is very hard to proceed the reaction. So to complete the reaction, it will take longer time. So to appear a turbidity, it will take more than 50 minutes. More than 50 minutes, right? So if you are primary like this, with anhydrous zinc chloride concrete Cl, it will take more than 50 minutes for a turbidity. Right? So by taking the count of the time taken to appear a turbidity with the Lucas reagent will account you for the primary, secondary, or tertiary nature of your alcohol. Right? If you're dealing with a tertiary alcohol, instant turbidity will appear with the Lucas reagent. If you are with a secondary alcohol, turbidity will be given in 5 to 10 minutes. But if you are dealing with a primary alcohol, it will take more than 50 minutes to appear kind of a turbidity. Right? So that is the idea, the Lucas test. So you can differentiate the primary, secondary, and tertiary alcohols, with the use of the Lucas test. It's the most important test in regard to alcohols. Right? Okay. Let's discuss about the other tests we can use to differentiate the alcohols as well. Right? Right. The second kind of test for the alcohols. So actually you can use the oxidizing agents here. Use of oxidizing agents. To identify the alcohols. Use of oxidizing agents to identify the alcohols. Right? Let's discuss about that thing. So alcohols are of three kinds. It could be primary, or secondary, or tertiary. So I'll write it here. It could be primary alcohols, secondary alcohols, or your alcohol would be a tertiary alcohol. Let's discuss how to differentiate these guys with use of oxidizing agents. Right? Okay. So if you are to use strong oxidizing agents like KMnO4 dichromate, what will happen? Right? If you use some H plus KMnO4 or H plus dichromate, for all the guys, let's use the stuff. Info here. So with primary alcohols, we will come up with carboxylic acids. We come up with carboxylic acids. Right? With secondary alcohols, you will come up with ketones. You will come up with ketones. But when it comes to tertiary alcohols, those won't get oxidized. No reaction. Tertiary alcohols can't be get oxidized. No, tertiary alcohols can't be oxidized because no hydrogens are appearing there to oxidize the stuff, right? So that is the idea. So with these two guys, how to differentiate the primary and secondary? How to differentiate the primary and secondary here? So if you are trying to differentiate the primary and secondary, right? You can use, right? You can use the test for carboxylates or ketones, right? So carboxylates and ketones, right? So basically, if you're at the add some reagent to identify differentiate these two guys, if you have to add some reagent to identify these two guys, right? This will give some positive answer, while this guy is not. So basically such reagents are there, right? Normally known as Brady's reagent, some for ketones, right? Such kind of reagents are there, right? So you can count with those, right? So that is one way of identifying the primary and secondary. So you can differentiate these two guys by adding some other chemicals, right? So that it will ultimately confirm the primary or secondary. මේ වැඩක් කරන්න පුළුවන් අර. දැන් මේ දෙන්නව වෙන් කරගන්න බෑනේ මේ විදිහට. ඔයාලා කරන් තියෙන්නේ මිදෙන වෙන් කරගන්න. මිදෙන්නවා අයිඩෙන්ටිෆයි කරන්න try එකක් දෙන්න පුළුවන්. අපි ඊට පස්සේ කතා කරමු ඊළඟ ටෙස්ට් එක කොහොමද මිදෙන්න අයිඩෙන්ටිෆයි කරගන්න කියලා. එහෙම රීජන් එකක් දාලා මෙයාව විතරක් ක්‍රියේට් කරන එකක් දැම්මම ඒකින් අපිට ඇත්තටම මෙයාගේ ප්‍රසන්ස් එක අයිඩෙන්ටිෆයි කරගෙන මෙයාව හොයාගන්න පුළුවන්. ඔය වගේ දෙයක් තමයි යන්න වෙන්නේ. හරි. Right. So we'll discuss about such things as well. ඒ වගේ එක දෙයක් කතා කරමු අපි ඔන්න. Right. First of all, with this one, right, the oxidizing agent decolorize, right? එකත් පොඩ්ඩක් ලියන්න ඕනේ නේද අපි? ලියගමුද? හරි මේගොල්ලෝ හැදෙනකොට එකත් පොඩ්ඩක් මාක් කරගමු මෙතනින්. එහෙම ලියමුනේ. So oxidizing agent decolorises, right? oxidizing agent decolorize වෙනවා. color change එකක් වෙනවා. color change එකක් වෙනවා. හරි මේ color change එකක් වෙන්නේ නැහැ. No reaction means no color change. Right? So අපි ඕන මෙන්න මේදී identify කරගන්න වැඩ ටිකක් කරන්න පුළුවන් ඕන මෙන්න මේ වගේ ටිකක්. Right? මෙහෙම ලියමු දෙක. That's right. ඔයාට මේකේ lithium aluminum hydride use කරොත් you will get the same primary alcohol. sodium borohydride use කරොත් there's no reaction there. දැන් මෙයා අයිඩෙන්ටිෆයි කරනවට තව වැඩක් කරන්න පුළුවන් ඕන. sodium carbonate type එක use කරොත් CO2 release වෙනවා. ඒත් මෙයාව අයිඩෙන්ටිෆයි කරගෙන වාට ඒකෙන් මෙයාව අයිඩෙන්ටිෆයි කරගන්න පුළුවන්. මෙයාව පොඩ්ඩක් කතා කරොත් එතන තව එකක් දාමුනේ. අර 2,4-DNPH දාන්න පුළුවන්. Brady's region කියන එක. අගින් රියැක්ෂන් එකක් වෙන්නේ නැහැ. මෙයාගේ වැඩි කතා කරොත් මෙයා 2,4-DNPH දැම්මම yellow orange compound එකක් තියෙනවා. This is known as the Brady's region. You can use the lithium aluminum hydride and as well as sodium borohydride to convert this guy to secondary alcohol. මෙයාට sodium carbonate දැම්ම කියලා reaction එකක් වෙන්නේ. Right? No acidity there to react with the sodium carbonate for ketones. Right? So this is how you're supposed to identify the presence of these two guys that will ultimately lead to identify the primary or secondary alcohol. Tertiary එක නිකම්ම identify කරගන්න පුළුවන්. Right? Okay? ඔය තමයි alcohols ලා කතාව. Right? Use of oxidizing agents. Right? I will thought reaction එකක් තියෙනවා බය අපි alcohols ලා identify කරගන්න. Let's discuss about that. The third one alcohols ලා identify කරන්න තුන්වෙනි reaction scheme එක. දැන් මේ දක්වා කතා කරලා ළමයි alcohols ලගේ primary secondary tertiary කට්ටියව differentiate කරගන්න හැටි. දැන් කතා කරන්න යන්නේ. හරි? වෙන compounds වලින් කොහොමද alcohols ලා identify කරගන්නේ කියලා. That is actual using its acidity. Using the acidity of alcohols. This is the acidity of alcohols, right? If you think of acidic nature of alcohols, right? See, you have alcohol. If you are to think of its acidity, alcohols will react with sodium to produce the alkoxide and H2 gas. So here you will get the colorless gas bubbles, but alcohols won't react with NaOH or with sodium carbonate. This is the acidic nature of alcohols. Only react with sodium, but not with the other two acids, other two bases, right? They have written this thing, but not these two guys. So just mark these two as well, that they are not going to react. This is about acidity of alcohols. Right, no? So this is all about the reactions involving alcohols. Alcohols lagata. Right. අපි ඔහොම යම් ළමයි ඊළඟට තරන්න වාගේ carbonyl compounds පැත්ත aldehydes ketones පැත්ත. ඉතින් අපි පස්සේ අපි යමු කතා කරන්න aldehyde ketones වලට. මේක ලියා ගන්න. Let's discuss about the identity test of carbonyl compounds. Right? Identity test of carbonyl compounds. Right. See, what are the carbonyl compounds? This number 5, no? Yeah, number 5. Carbonyl compounds. Right? What are these carbonyl compounds? The carbonyl compounds are normally the aldehydes and ketones, right? Carbonyl compounds are those, no? Normally the aldehydes and ketones. Right? Let's discuss about those. Right? First thing, let's discuss about the identification of the carbonyl bond. Of carbonyl bond or carbonyl group. Sorry, carbonyl group. like carbonyl group එක කියලා කියන්නේ මේ අර aldehyde ketones ලත් එක්ක තියෙන section එක. හරි කියන්නේ මේ carbonyl group එකක් වෙන්න නම් අනිවාර්යෙන්ම වාගේ හරිද? මේ දෙපැත්තේ තියෙන්න ඕනේ hydrogen නැත්තම් R විතරයි. හරි? දෙපැත්තෙම R නැත්තම් hydrogen ඉන්න ඕනේ. carbonyl group එකේ. aldehyde ketones තමයි set වෙන්නේ. එක්ක aldehyde නැත්තම් ketone. හරි? ඒතර වෙන්න මේ group එක තමයි carbonyl group එක කියන්නේ. වෙන්නේ මේක. හරි? මේක. දෙපැත්ත set වෙන්න ඕනේ hydrogen කෙනෙක් නැත්තම් organic විතරයි හොඳේ. මේක වුණොත් බෑ හොඳේ. OH groups එහෙම set ලා හරියන්නේ නැහැ හොඳේ. OH group Cl ලා. ඒතර carbonyl group වෙන්නේ නැහැ හොඳේ. මේව set වෙන්න ඕනේ. It is a carbonyl group, right? Let's discuss, right? So the test to identify this carbonyl group is known as the Brady's test. Do you know Brady's test again? Brady test. Right, we are going to do the Brady's test. So let's discuss about that thing. How this happens when you are with a aldehyde or a ketone, or even with a this kind of stuff, right? Right? Mega CHO yakari COR yakari benzene aldehyde benzene ketone, benzene aldehyde benzene ketone, right? Aromatic ketone. Mega. These are aldehydes, ketones. මේ ඕන එක්කෙනෙක් ළමයි ඔයා Brady region දැම්මොත්, if you add the Brady's region, you add the Brady's region. Let's take it as Brady region, no worries. Right? So Brady region is what? It is actually called as 2,4-DNPH, known as 2,4-DNPH. This is the Brady's region, right? 2,4-DNPH, right? What that means? 2,4-DNPH කියලා මොකද්ද? එන්න මේස් එක 2,4-DNPH කියලා කියන්නේ හරි? It's like this. DNPH means it is like dinitrophenylhydrazine. Dinitrophenylhydrazine. So Brady's reagent is known as 2,4-dinitrophenylhydrazine. 2,4-dinitrophenylhydrazine. Right? Dinitrophenylhydrazine. So let's draw the structure. Drawing the structure is very important in this case, right? Dinitrophenylhydrazine. So you start drawing the structure from here. Hydrazine. Hydrazine. Start from hydrazine. Dinitrophenylhydrazine to start from hydrazine. So hydrazine is like this. This is known as the hydrazine. This is hydrazine, right? This is hydrazine. But what we need is not the hydrazine, but the phenylhydrazine. Phenylhydrazine. Phenyl means when the benzene ring is as a substituent group. When the benzene ring is as a substituent group, it is known as a phenyl group. So now this is phenylhydrazine. Earlier it was hydrazine when the hydrogen is there, N2H4, right? Now it is phenylhydrazine. So what we need is dinitrophenylhydrazine. Dinitro. 2 nitro groups should be there. At which positions? At the second and fourth positions. At the second and fourth positions, 2 nitro groups should be there. The second position means 1, 2. This is second position. 1, 2, 3, 4. Fourth position is this. At the beginning of the lesson, I have told you how to number the positions in your benzene ring. Number 1 is always given to the connected position. Number 2, 3, 4. Right now? So second and fourth positions carrying some nitro groups. So 2,4-dinitrophenylhydrazine. Right? This is your Brady's region, right? So let's discuss about the observation if you add Brady's region to one of these aldehydes, ketones, or benzaldehyde or benzene aromatic ketone. So what will happen is actually, right, this part this NH2 part will leave with this part of the bond, with the double bond oxygen bond. This NH2 part will leave, right? So then what will happen? So this nitrogen will connect to this carbon. This nitrogen will be connected to this carbon, right? By leaving the 2 hydrogens and oxygen. By leaving H2 molecule with those 2 bonds, the nitrogen will connect to this carbon, right? That is your compound ultimate. So you will come up with like this. So your carbon is like this, right? So some 2 bonds, with that nitrogen will be connected, this nitrogen, right? So you have this nitrogen and the rest of the 2,4-DNPH. Right? Okay. So you could have some hydrogen or R group or a benzene ring here, right? So this is the compound, and this can be seen as a yellowish or orange colored compound. This is kind of yellow or orange compound. It can be taken as a precipitate or as a solution, no worries, right? So this is the observation. So what happens is actually these 2 hydrogens will release with this oxygen or with this oxygen. That carbonyl oxygen will leave, right, with these 2 hydrogens. That is how the yellow or orange color compound is formed. So only with the aldehyde ketones this kind of reaction is possible. Only with the aldehydes and ketones this kind of reaction is possible, right? So this Brady reagent is referred to as the reagent to identify the aldehydes and ketones, right? Reagent to identify the aldehydes and ketones. Somewhere ඔයගොල්ලෝ note එක මෙන්න මෙතන පොඩ්ඩක් හදා ගන්න. It should be a R group, right? There should be a R group there in your note. R group එකක් වෙන්න ඕන. Right නේ? ඔතන Brady reagent එක කතාව. So that is used, or the Brady's reagent, right? That is used to identify the aldehydes and ketones from other organic compounds. Right? So it is Brady's reagent. හරි. දැන් අපි කතා කරමු ඊළඟ ටෙස්ට් එක. හරි. මොකක්ද අපි use කරමු ඊළඟ ටෙස්ට් එක මොකක්ද කියලා to identify the carbonyl compounds, right? So actually next test we are going to use is actually about some test to identify the aldehydes only, not for the ketones but for the aldehydes. So the logical background here is, here we are going to use this. Actually aldehydes can be oxidized, no? Aldehydes can be oxidized but not the ketones. So we are going to, right, come up with some reactions involving aldehydes only, some oxidation reactions, right? Okay, let's come up with that. Right. Okay, these were aldehydes. Only for aldehydes. Here we are supposed to use the oxidizing agents. Oh, we can write like this. Oxidizing agents will react with aldehydes but not with ketones. So earlier with the Brady's reagent, we can differentiate, so we can separate the aldehydes and ketones from other compounds. That is only what we can do now with the Brady's reagent. With the Brady's reagent, you can't separate the aldehydes and ketones. You can't differentiate the aldehydes and ketones. But what we can do is, we can separate them from other compounds. Brady's reagent එක කරන්න පුළුවන් අනිත් compounds ලගින් aldehyde ketones වෙන් කරගන්න හඳුනගන්න විතරයි. එතකොට Brady's reagent එකේ aldehyde by ketone නයි වෙන් කරගන්න බෑ. aldehyde by ketone නයි දෙන්නව හඳුනගන්න වෙන් කරන්න Brady's reagent එකෙන් බෑ. So that to do so, to confirm whether it's aldehyde or a ketone after the Brady's reagent, right? So we need one of these kind of tests, right? So tests involving oxidizing agents, right? So let's discuss about those, right? So this is all about the reactions for aldehydes, right? Let's say you have aldehyde here, you have aldehyde here, right? Let's discuss the tests we can use. So basically we can come up with the Brady's reagent. Right, that will react with the ketones as well. Anyway, the aldehydes will give you some yellow orange compound with the Brady, right? So what else we can use? You can come up with the tolerance reagent. You can come up with the tolerance reagent. What is this tolerance reagent? Tolerance reagent is ammonical silver nitrate, right? One can write it like this, or one can write it like this. Right? Oh, one can write it in letters as well. Right? You can use the ammonical silver nitrate as well. So what will happen? So there will come up with a silver mirror. This thing is also referred to as silver mirror test. Right? If you add some tolerance reagent to aldehydes and ketone, to aldehydes, you get a silver mirror. Right? That this is also referred to as silver mirror test. So there, the Ag plus reduces to silver. Ag plus reduces to silver, while the aldehyde will oxidize to carboxylate anion. Carboxylate anion. Right? Ag plus reduced to silver, while the aldehyde will oxidize to carboxylate anion. It is very important to note that it should be towards the anion, right? Why we are saying so? Why we are saying so? Because the medium is acidic. Sorry, the medium is basic. The medium is basic, ammonical medium. Medium is basic, so carboxylate anion is the one to produce, right? So then Few other tests can be done to identify the aldehydes. Another one is the Fehling's test. Fehling's test. Fehling's reagent. So it is known as the basic copper 2 plus tartrate. Basic 2 plus tartrate. Right? There what will happen? So there, while copper 2 plus reduces to copper 1 plus, copper 2 plus reduces to copper 1 plus. So BCuO is a brick red precipitate. And the copper 2 plus reduces to copper 1 plus, the aldehyde will oxidize to carboxylate anion again. Carboxylate anion again. Why? Again the solution is basic. Again solution is basic. You are not supposed to get the carboxylic acid. As the solution is basic, it is the carboxylate anion again. Even in here, the solution is basic, so you will produce the carboxylate anion. If you had written this as carboxylic acid, it is wrong. Huh? You won't get marks. It should be carboxylate anion. As the solution is basic in both of those situations. Or one can come up with acidic KMnO4O, acidic dichromate as well. Right? D block oxidizing agent. So you can come up with KMnO4O acidic dichromate. Right? So there, the KMnO4 will decolorize to Mn2 plus. Right? The dichromate will convert to Cr3 plus. Color will change, while the aldehyde oxidizes to carboxylic acid. Because the medium is acidic now, so it will oxidize to carboxylic acid, right? So here what happens is MnO4 minus goes to Mn2 plus. So it is purple color decolorises. Purple to colorless. O your dichromate decolorises to Cr3 plus, no? Green. Right? So while that occurs, the carboxylic acid towards carboxylic acid, the aldehyde will oxidize. Right? Towards carboxylic acid, the aldehyde will get oxidized. Right? As it's acidic medium, so you will come up with the carboxylic acid. No one is there. But with these two guys, it's very important to note that you get the carboxylate anion, not the carboxylic acid, right? Okay? So that is the idea. So that is all about the situation with the aldehydes. So with the use of these three tests, which are known as using oxidizing agents, right? You can differentiate the aldehydes by ketones, because ketones are unable to participate in oxidation reactions. Only the aldehydes will do so, right? No? This is very important, right? So just color this stuff, right? And this tolerance reagent test is also known as the Stiller mirror test, right? Stiller mirror test. Stiller mirror test හරි මේ ටෙස්ට් එක කොට එක ළඟින් යන්න filamenta test and the failings test. Right. So at the bottom part of the page number 26, some more data are there. Let's discuss about that thing as well. Some special things appearing with these reactions. Right? For the area කතා කරලිමු. Right? හරි. Next one. Okay? Some special note. Right? This is going to be a special note, right? Right. Even though benzaldehyde is kind of an aldehyde, benzaldehyde is an aldehyde that won't react with Fehling's reagent. It is special, no? It's a special thing, right? So even though the benzaldehyde is an aldehyde that won't react with Fehling's reagent, right? So what it says like this now. So it goes benzaldehyde it's an aldehyde, right? Okay. It will react with Brady. It will react with Brady, right? To give you the orange yellow compound, no worries there. It will react with Tollens to give you the Siller mirror. No worries there. But the problem is with the Fehling's. It's known as the basic copper 2 plus tartarate. Right? There are no reaction. Especially note that it's a very special thing. Some VIB situation appearing with the benzaldehyde. And it will get oxidized as well, right? No worries with that as well. The oxidizing agent. Yeah, also no worries. Color change in oxidizing agent. But this is a special thing to note that with the Fehling's reagent, no reaction with the basic copper 2 plus tartrate, no reaction with the benzaldehyde, right? It's a special note, right? Okay, the second special note. The second special note is actually regarding the formic acid. Regarding the formic acid, right? Even though formic acid, HCOOH, is not considered as an aldehyde, still it gives positive results for aldehyde identification. Tests involving oxidizing agents. Right? See, so this is formic, the simplest carboxylic acid. No, the simplest carboxylic acid, right? Right? So if you had a 2,4-D pH, Brady, right? That won't react, huh? That won't react. It is not a aldehyde or ketone. That won't react, right? But with the other three, which are known as oxidizing agents, tolerance reagent, Fehling's reagents, as well as D block oxidizing agents. D block oxidizing agents, right? The positive observations will occur. This is tolerance reagent. You will get the Ziller mirror. With the Fehling's reagent, you get the Bricktade PPT. Right? With the oxidizing agents, the color of the oxidizing agent will change. Color change of oxidizing agent. Those things will occur. Actually, why is that? The reason is actually it is with kind of a aldehyde kind of section. It is with aldehyde kind of section. That this thing will get oxidized. This thing will get oxidized with the oxidizing agents. But this section is not considered as a carbonyl group. That is why the 2,4-D pH is not giving its positive result. But this section can be get oxidized. So with the oxidizing agents, the positive oxidation will occur. Right? So we can think of another one special reaction there. The one special reaction with some concentrated H2SO4 and heating for this stuff. So H2SO4 is considered as a dehydrating agent, right? H2SO4 is considered as a dehydrating agent. So that this guy will dehydrate, right? So it will leave this H2O part, it will leave this H2O part to come up as carbon monoxide. So as this H2SO4 is kind of a dehydrating agent, the H2O will be absorbed by the H2SO4. So CO gas will release. Right? That is a special observation. Carbon monoxide will be released, right? Because of H2SO4. These are some special reactions involving the formic acid, right? With this part, oxidation could occur. That is why this guy responds to the test involving oxidations, right? And with the concentrated nitric, it is a dehydrating agent. So the H2O molecule will release to come up as carbon monoxide, right? No? Okay. These are some special things you should know about the formic acid, the simplest carboxylic acid, right? The third point there at the IDMA tests for the aldehyde skin ketones is actually regarding the tolerance region, right? Third one. The terminal alkynes, even though it is not the aldehyde or ketone, terminal alkynes will also react with tolerance reagent. Tolerance reagent. What is this tolerance reagent? There is the ammonical silver nitrate, right? In this case, the important thing to note that is actually here, not like in aldehyde situation, right? You are not going to give you a silver mirror here. With the terminal alkynes, you get a white PPT. So with aldehydes, the tolerance reagent, you get a silver mirror. Right? But with terminal alkynes, the same reagent, tolerance, you will get the white PPT. This silver mirror, then this is white PPT. පොඩ්ඩක් ළඟින් යන සිග්නයක් තියෙනවනේ. නුඹලා ළඟින් යන ගතියක් තියෙනවා ඒකේ හරි. The white PPT is due to the formation of this thing. This white PPT is silver mirror. This is not a precipitate, right? This is just silver mirror. It's not a precipitate, but here it's a precipitate, right? Those are the two things. With the aldehydes as well as terminal alkynes, the tolerance will react. Right? Okay, and this is regarding as a regarded as a redox reaction, and this is regarding as a precipitation reaction. Two kind of reactions, right? Here the no change in oxidation state occurs, right? Here the oxidation state will change, right? As aldehyde oxidizes to carboxylic, right? Some oxidation, carboxylic, some oxidation will occur. But here it's a precipitation reaction, right? Two kinds of reactions, right? Okay, right. Those are the three special stuff you should know about the aldehyde ketone INV test, right? Okay. Finally, let's move towards the carboxy acids, right? INV test of carboxy acids. Number 6. INV test of carboxy acids. No. Okay. This is about the INV test of carboxy acids, right? So few INV tests are there with carboxy acids. All of you know that carboxy acids are acidic, right? So you could think of tests involving acidity, right? These are acidic. So tests involving acidity, right? Can be used to identify them. So basically, right, the most important reaction here is the use of sodium carbonate or sodium bicarbonate. There the CO2 gas will release. CO2 gas will be released. It is very important, right? Right. So it will react with sodium to produce the H2 gas. Again, colorless. Gas bubbles, right? Then what else? So carboxylic reacts with alcohols to produce esters. Alcohols in the presence of conc H2SO4 catalyst. It produces esters. It produces esters, which is very important, no? Production of esters. So esters are known as some compounds is present smell. Right? Then what else we can use to identify the carboxylics? Right? So basically, if you were to apply the lithium aluminum hydride, it will give you primary alcohols, and with the sodium borohydride, no reaction. Carboxylic derivatives won't react with sodium borohydride. Right? So those are the important reactions we could think of identifying carboxylates. Right? Right now, this is about the carboxylates. This is very important. This is very characteristic for the carboxylates, right? Okay. Right. That is all about the identifications of carboxylates. Right? Okay. So with this, we had done discuss about all the identification tests involving the organic compounds. Right? So these are very important for your question number 4, the isolation question, as well as for your MCQs. Right? With the next class, we'll discuss about the isolation. Right? So that you will see how important these observations, these identification tests are. Right. So that's it for today. Then we'll wind up at this session from here. So next week we'll join with the isolation. Goodbye. See you next week.